Is it visible to you guys? The slide?
Yes, sir.
Okay, so today we are gonna discuss chapter 7, that is about kinetic energy and work. Kinetic energy and work, and this is most probably on the last chapter in mechanics. So let's discuss what is kinetic energy, what is work, and so on and so on. So you guys already know what is kinetic energy is. Kinetic energy. At first, let me tell you what is energy. Energy is something that gives the ability to do some work. হ্যাঁ, তো অবজেক্টে এনার্জি থাকলে সে কি করতে পারে, কিছু ওয়ার্ক করতে পারে। ওয়ার্ক করার অ্যাবিলিটি হচ্ছে এনার্জি, এবং the kinetic energy is very much related to the motion. The energy of a moving object is called kinetic energy, or the energy that an object gain due to its motion is called kinetic energy. For example, here it is kinetic energy is defined as
স্যার ক্লাস কি রেকর্ড হচ্ছে?
yes, record হচ্ছে।
Yes, sir. Okay, sir.
Okay. So now আমি একটু পেনটা একটু নিয়ে আসি। So my kinetic energy is defined as, if m is the mass of an object, so kinetic energy is defined as 1/2 into mass times velocity square. Okay, mass times velocity is square. So this is the definition of kinetic energy. So this is a very easy formula. You guys already know this. And by the way, unit of energy and kinetic energy are same. Unit of kinetic energy is joule, denoted by J. So okay, actually in today's class we are going to focus more on the problem solving thing. So let's solve a math. I think you can see it here. So it is saying that in 1896 in Waco, Texas, William crashed Part 2 locomotive at opposite end of a 6.4 kilometer long track and fired them up, tied their throttles open, and then allowed them to crash head on at full speed in front of 30,000 spectators. Hundreds of people were hurt by flying debris. Several were killed, assuming each locomotive weighing 1.2 into 10 to the 6 Newton, and its acceleration was a constant of 0.26 meter per second square. What was the total kinetic energy of the two locomotives just before the collision? So the thing is, what it is saying that in 1896 in Texas, somewhere Texas, at a experiment like there was a 6.4 kilometer long track. Okay, and এই দুই এন্ডে দুটো লোকোমোটিভ ছিল, or let me tell it, like ইঞ্জিন ছিল, দুটো ইঞ্জিন ছিল, and you can see and then সেটাকে উনি initial velocity ছিল 0. Okay, both of them have the initial velocity of 0. এখন তাদেরকে একটা acceleration দিলেন, and with an acceleration a equal to, you see here it is saying 0.26 meter per second square, 0.26 meter per second square, same here as well, 0.26 meter per second square. তারা কি করলো, অপোজিট দিকে মুভ করলো। Okay, this is moving in opposite direction. তাহলে কি হবে, at some point, this is 6.4 kilometer, at some point it will come this way, this locomotive will come this way, and at some point they are going to collide. Okay, they are going to collide. They are going to collide with each other. এবং যারা যখন collide করে, দেখো তার ট্রাভেল করলো কতটুকু, they travel like 3.2 kilometer, এবং this 3.2 kilometer travel করার জন্য তারা কি করলো, they gain some kinetic energy, it will travel করে, the velocity to increase করতেছে at a rate of 0.26 meter per second, এবং এই এনার্জিতে তারা কোলাইড করলো। What I have to find the total energy during this collision. এখানে বলছে কলিশনের জন্য গাড়িগুলো পুরো ভেঙে গিয়েছিল, and flying এই ডেব্রি যেগুলো ছিল, যে ভাঙা টুকরোগুলো, এগুলো তো আঘাতে অনেক মানুষ মারাও গিয়েছে। So I have to find out the kinetic energy, total kinetic energy here during the collision. Is it clear? ম্যাথটা কি ক্লিয়ার হয়েছে? আমি বুঝতে পেরেছি? So now so I have to find out the total kinetic energy. Total kinetic energy means আমি বলি যে kinetic energy of each car, kinetic energy of two locomotive. Okay, locomotive, and each locomotive are same, they have same mass. Okay, weight দেওয়া আছে, weight it is given here. So this is 2 into kinetic energy of one locomotive. Okay, 2 into এটা কি বুঝতে পারলা? Kinetic energy of 2 locomotive equal 2 into kinetic energy of each locomotive. This is because দেখো ম্যাস প্রত্যেকটা কারের ম্যাস সেম এবং প্রত্যেকটা লোকোমোটিভ বা ট্রেন যেটা করবে কি একই সেম ডিসটেন্স ট্রাভেল করবে at the same acceleration with the same initial speed, তাহলে during collision তাদের ভেলোসিটি কিন্তু সেম থাকবে। তার মানে কি তাদের ম্যাস সেম, ভেলোসিটি সেম, তাহলে তাদের কাইনেটিক এনার্জিও সেম। That's why I write here kinetic energy of this locomotive plus kinetic energy of this locomotive, that is equal to 2 of kinetic energy of one of the locomotive. And kinetic energy of one of the locomotive, each locomotive is mass times half into mass times velocity square, half into mass times velocity square. So basically the total kinetic energy equal to the total kinetic energy equal to mv square. Now this value will give me the total kinetic energy. Now what is the mass of the object? Mass. Therefore here the m is the mass of each locomotive, but locomotive এর mass দেওয়া নাই, এখানে তারা বলছে যে weight of a locomotive is 1.2 into 10 to the power 6 Newton. So weight equal to, if my weight is equal to 1.2 into 10 to the power 6 Newton, then my mass equal to what? Weight per g. So this should be like 1.2 into 10 to the power 6 Newton divided by g. Right, g is my 9.8, g is 9.8 meter per second square. So if you just calculate this thing, you are gonna get use a calculator. It should be around like 1.1 into something. Use the calculator. Should be like 1.2. This should be 1.22 into. So my AM equal to 1.22 into 10 to the power 5 kg. This is the mass, and then velocity. Velocity is what? Velocity, my initial velocity of each locomotive was 0, and this velocity after traveling 3.2 kilometer is v. This is the velocity after traveling 3.2 kilometer. Its total track is 6.4 kilometer. Okay. So now I know velocity square equal to u square plus 2a into displacement x. So my u is 0 here. So v equal to basically square root of 2a into distance x. So here my 2 acceleration is given 0.26 meter per second square, 0.26, and weight or mass, and the distance is 3.2 kilometer, that is 3200 meter. So this is basically, you have to do the calculation now. Calculation করতে পারবে? পারবে না ক্যালকুলেশনটা করতে বাবা? I left it for you guys. So what you have to do, you have to replace this value of v and mass over here, and this will give you the result. This will give you the result. এবার থেকে আরো কিছু বলার দরকার আছে? Hello?
No, sir.
So I'm going to end at the comparable. And then let's move to the next thing. What is work? Work is basically means transformation, a form of energy transferred from an object by means of force acting on an object. I'm going to connect the object but the force apply kori. Some energy got transferred from myself to that object. A জিনিসটাই হচ্ছে work done. Or in other word, আমরা বলি যে if some force is applied to an object and because of this, if the object travels some distance, we can say that some work is done on the object. So work done করা মানে object is work done করেছে. This is because I give some energy to that body. Okay, so this is the work. We all, I think, know this thing. I just want to tell you guys how to define the work. Keep work defined for you. Even though you guys already know these things. So work is defined as like if I have an object here and a force F is applied on it, like F is the force that is applied on it, and because of this, the object travel a distance T. in this way. Okay. So if F is my force, if a force F is applied on an object, and because of this, the object travel a distance d, or its displacement is d, then I can say work is equal to F dot d. So basically, work is the dot product between force and displacement. And since this is a dot product, work is a scalar quantity. Okay. And if this angle between force and distance is phi, or displacement is phi, if the angle between force and displacement is phi, so we can write work done equal to Fg cosine of phi. So we can write this in work done equal to Fd cosine of phi. And now just have a look at one thing. If what happened? Two things can happen here. Let's say I'm applying a force, this special case, I'm applying a force on an object here, and because of this, the object is traveling in the same direction. Displacement is along this way. That is, distance between force, like direction between force and displacement here is 0. Force যে direction কাজ করছে, displacement is also acts along the same direction. So in that case, angle between force and displacement is 0, and we can say W equal to here, W equal to Fd cos phi. That means equal to Fd cos 0. So W equal to Fd. So oftentimes we use force is a multiplication is equal to multiplication of force times distance. A জিনিসটা basically applicable only when my force and displacement are acting along the same direction. Okay, যখন both of them acts along the same direction. And I can tell you guys one more thing, like say another example is like a force is acting along this way, and by somehow, because of this force, the displacement is acting along opposite direction. Okay, the direction between force and displacement are opposite. That means angle between them is what? Angle Fd cosine of phi. Angle কত বলো না ভাই? F আর D এর মাঝখানে? হ্যালো হ্যালো, কথা শুনতে পাচ্ছ তোমরা? হ্যালো, হ্যালো, আমার কথা শুনতে পাচ্ছ?
জি স্যার।
ওকে, ঠিক
আছে, শোনা যাচ্ছে।
আচ্ছা, ঠিক আছে, আমি অ্যাঙ্গেলটা জানতে চাই। এনিওয়ে, so angle is 180, so cos 180 means minus, so work done equal to minus Fd. So work can be negative as well. Work can be negative as well. So work done negative means the thing is force and direction are acting in the opposite direction. The direction between force and displacement are opposite. Okay, so this is the thing. আমরা কিছু ম্যাথস করব এর উপর বেস করে, and now let's derive a relation between the force and kinetic energy. Let's see what is the relation between force and kinetic energy. Okay, so now আপনারা জানি, let's think that an object having mass, I have an object that has a mass of m and that has an initial velocity of u. Okay, an object has a mass m and has the initial velocity of u, and a force F, and the force F acts on it. A force F acts on it, and because of this force, যখনই একটা object উপর force কাজ করে, we know that when a force acts on an object, then its motion or state of motion got changed. So let's say a force F acts on it for t seconds, and because of that, it travel a distance like s. A distance traveled by the object is s, and after that it's reached this point, and at this point its velocity become v. Okay, a object having mass m and has the initial speed of u, and when a force F acts on it, because of this force, its velocity changes from u to v, and during this time it travels a distance of s. And now for this object, I want to find out the work done, and also I want to find an expression, a relation between work and kinetic energy. So now here is the thing. So work done is what? We know work done, work W equal to force times force or displacement. And by the way, here force and displacement are in the same way. As an axis, and a phone book. sorry. So force is work equal to force dot displacement. So basically the distance between force and displacement, force is this way, and displacement is also along the same direction. So the distance between the angle between them is 0. So work is Fs cosine of 0, that is Fs. So I'm going to declare the work equal to force times displacement here. Okay, this is a relation. And now look here, if S is my displacement and initial speed is u and final speed is v, we can say v square equal to u square plus 2as. We're considering that a is the acceleration, here. So from here we can say 2as equal to v square minus u square, or like s equal to v square minus u square over 2a. A is my acceleration. Okay, A is my acceleration. So now, and also A is acceleration. If A is acceleration, if A is acceleration, then A is equal to v square minus u square by 2a, and also we can say F equal to mass time acceleration. Okay. Now what I can do, I can substitute this value of F and S in this expression, and we can get, so we can write W equal to F is MA times V square minus U square over 2 A and A are gonna cancel each other, so this will be like M over 2 V square minus U square, or we can say W equal to 1/2 mv square minus 1/2 mu square. So look at this thing. This is the kinetic energy when velocity is v, or we can say this is the final kinetic energy, and this one is the initial kinetic energy. So we can write W equal to final kinetic energy. I can say like kinetic energy final minus kinetic energy initial, or we can say W equal to change in kinetic energy. Okay, so this is basically, this is a relation between work done and kinetic energy. This is the relation between work done and kinetic energy. এবং এদের প্রত্যেককেই অবশ্যই একটা নামে আমরা চিনি, we call them principle. একটু বলবো এটা কি বলি, what it is called? It is called work energy theorem. This is called work energy theorem. What does work energy theorem says? It says that work done is equal to the change in kinetic energy of the system. So this is called work energy theorem. And this is a very important theorem, and we're going to use it for solving some math. This is the famous work energy theorem. Okay, this is the famous work energy theorem. Okay, so what energy theorem already boiled. Okay, so let's try a math now. Let's try a math now. This figure shows two industrial spies. They are sliding an initially stationary 225 kg floor safe a displacement of d along d of magnitude 8.5 meter. The push F1 of spy 001 is 12 Newton at an angle of 30 degree downwards. So this is spy 001. He's pushing it downwards. Downward push this way, like this way downward. That is making an angle 30 degree with the horizontal, and the push F2 from the spy 002, she push korche upward dike edike push korche at a force of 10 Newton, and that makes a 40 degree of the horizontal সাথে 40 degree produce korche, force apply korche. I have to find out the so the magnitude and direction of the force do not change as the shape moves. So যখন shape move করে, force টা constantly থাকে, force টা change করে না. What I have to do, I have to find out the net work done on the shape by the force F1 and F2. So এই shape টা যখন তারা move করছে, কত distance দেখো, 8.5 meter. এটুকু distance move করলে পরে total work done কত করছে সেটা ফিগার আউট করতে হচ্ছে. I have to find out the total work done. Okay, when he move by force F1 and F2. A push করছে, A pull করছে, এবং এই দুটো ফোর্সের জন্য this is my F1 and this is F2, এর জন্য total work done কত হচ্ছে. আমি যদি what I can do at first, I can draw a free body diagram. A free body diagram is like, this is the object, okay? And the object is traveling along x direction, like this way. Okay? So F2 is acting downward. This is my F2, this is acting downward. And this is making an angle theta or 30 degree with the x direction. And F2, that is the pull of SPY 2. তোমরা কি দেখতে পাচ্ছ? Hello?
Yes, sir.
Yes, sir.
Thank you. So this is my F1 and this is the F2, is the push by second guy. It makes an angle 40 degree. And the object is moving to the positive x direction. This displacement is along this way. Displacement is along this way, okay? And here the magnitude of displacement is given. Magnitude of displacement is 12. Magnitude of force F1 equal to 12. No, magnitude displacement is 8.5, by the way. And F2 equal to what? F2 equal to 10 Newton. So now total work done. Total work done is what? Total work done equal to, I'm going to put work done by SPY1 plus work done by SPY2. By the way, since work done are scalar quantity, we can just add them up algebraically. Algebraically add করতে পারি. So work done equal W1 plus W2. Here W1 is what? W1 is the work done by SPY1. So work done by SPY1 or work done by force F1. Okay. So work done by force F1 is equal to F1 D cosine of angle between F1 and D. Angle between F1 and D is 30 degree. Okay. So this is basically F1 is 12. My D is like 8.5 and times cosine of 30. Do any of you have a calculator with you guys? Or should I calculate first?
Yes, sir.
Calculate. No.
Sir, 88.334.
88.334. 88.33. Let's say this is Joule. And also similarly work done by the SPY2. So his force is F2 and he's traveling the same distance D, and the angle between force 2 and displacement is 40 degree. So cosine of 40 degree. So this is basically 10 into D is 8.5 into cosine of 40. So what is value is?
Sir, 65.113.
65.11 Joule. So then we can find the total work is W, that is equal to 88.33 plus 65.11, and then it should be equal to 0.44.
153.44.
53.44 Joule. Okay, so this is the total work done. This is the total work done. Okay. And then this math has a second part, and the part B. Let's see what the part B is. It is saying during the displacement, the work WG done on the shape by the gravitational force, and what is the work WN done by the normal force. Okay. So we see when I have a shape here, there can be a number of force here. One is called, I think we already discussed, gravitational force is always acts downward, gravitational force. And যখনই তুমি একটা অবজেক্টে একটা সাপোর্টের উপর রাখো, the support acts a upward force on it, that is vertical normal to the surface, that is called normal force, Fn. So now what I have to find, I have to find out the work done by the normal force and work done by the gravitational force. So the scenario is like, to do the math, let's draw a free body diagram first here again. So this is my shape, this is the normal force Fn, and this is the gravitational force, this thing. And the displacement is along this way, along x direction. So work done by the normal force or gravitational force Wg is equal to Fg, the force dot displacement, right? So my Fg times d times cosine of angle between this force and this displacement. So what is the angle between FG and D? The angle is 90 degree. FGD cosine of 90 degree and cosine of 90 equal to 0. And 0 multiplied by anything equal to 0. Right? So work done by gravitational force is 0. And also work done by the normal force. Work done by the normal force is same again, equal to Fn dot D. Okay. So this is basically a normal force times distance times cosine of angle between them. So normal force is acting upward, vertically upward, and angle between displacement and Fn is 90 degree again. And then this is basically equal to 0. So what I mean by gravitational force and normal force both are 0. So is it clear?
Yes, sir.
Yes, sir.
In the part C, they are saying the safe is initially stationary. Initially, the safe is stationary. Initially, it is stationary chilo, and then after traveling 8.5 meter, it could move kollo, and after what is the speed? A VF at the end of 8.5 meter displacement. Initially, the safe was initially, let us say this the safe. এখানে দুটো ফোর্স কাজ করছিল, one is F1 আর একটা F2. So sorry, F2 is this way. এখন initially it has velocity 0. এখন বলছে যে সে তো কি করলো, the safe was travel to a distance of 8.5 meter, তাই না? এখানে ট্রাভেল করে তারা নিয়ে আসলো সেফটাকে। এখন what is the velocity at this point? What is the velocity at this point? VF. Is it clear to you? 8.5 meter distance travel করার পরে এটার velocity কত? VF. So you see, velocity figure out করতে হবে. And to solve this math, we can apply work energy theorem. So the work energy theorem tells us work done equal to change in kinetic energy, or we can say like, okay, 1/2 m VF square. This is the final kinetic energy. এটা তুমি এরকম বলতে পারো, kinetic energy final minus kinetic energy initial, right? So it is my final kinetic energy minus initial kinetic energy is 1/2 times mass time initial velocity square is equal to work done. And work done for traveling 8.5 meter, we already calculated, which is 153.44 joule. So this is basically 153.44 joule. Okay. Okay, this is 144 joule. And by the way, initial velocity VI is equal to 0. So that means this guy will be equal to 0. And we can say VF square 1/2 m VF square equal to 153.44, or VF equal to 2 into 153.44 divided by m. M is the mass of the object, which is given over there. Mass is 225 kg. 225 kg. So this VF square, by the way, this is VF square. So we can say VF equal to square root of 2 into 153.44 divided by mass is 225 kg. So if you calculate this, this will give you the answer. This will give you the answer in meter per second. Is it clear? I think
Yes, sir.
You must understand this math. So, and then here is another math. During a storm, a crate of crepe is sliding across a slick, wily parking lot through a displacement of D. D is given 3I. While a steady wind pushes against the crate with a force of 2I minus 6J. The situation and coordinate are shown here in this figure. How much work done? How much work does this force do on the crate during this displacement? So at a parking lot, at a crate ছিল, যে কোনো কিছু crate হতে পারে, and then at a force, when a force is applied on it, this is given 2I minus 6J. It travels a distance of minus 3I. Okay, a force applied করলেন. What I have to do, I have to find out the work done. I have to find out the work done. So the force is given, force and displacement are given here in unit vector notation. I have to find out the work done. By the way, we know work done is equal to, work done equal to force dot displacement, right? This is the work done. force and displacement, dot product of force and displacement will give you the work done. So we know the force here and displacement here. So what we can do, we can say like, okay, force equal to, let's say force equal to 2I minus 6J. This is my force, and my displacement equal to minus 3I, and let's say 0J, right? Okay. So this is force and this is displacement. So then work equal to F dot D. This is basically, I have to take the dot product of these two. So 2 multiplied by minus 3 plus minus 6 multiplied by 0. 2 multiplied by minus 3 plus minus 6 multiplied by 0. So that is equal to minus 6 and unit is joule. So work done equal to minus 6 joule. Is it clear? So this is how we can find out the work done even if the force and displacement are given in unit vector form. Okay. Let's move forward. Work done by gravitational force. So work done by gravitational force. Let's think. We all know about the gravitational force, right? I think the chapter 4, we know gravitational force is the pull towards the Earth. There's a gravitational force, and gravitational force always acts downward, works downward. Gravitational force, for example, can work on an object in two ways. One is pulling an object, pulling up an object. It's like the object was initially here, okay, and you pull it up to here by a distance of h. H distance upward like object. Upward h distance travel for object of the mass হচ্ছে m. m mass এর objectটাকে h height উপরে উঠালা তাহলে কতটুকু work done করে. By the way, the gravitational force is Fg. It's act downward. So work done during pulling up an object by a height h equal to force dot displacement. Okay, Fg dot h. And by the way, Fg is acting downward, h is acting upward. So the angle between them is how much? One is upward, h, and Fg is downward. An angle between them is 180 degree. So that is minus. So this is Fgh. Or we know Fg equal to mass times gravitational acceleration due to gravity, Mgh, and minus. Oh, by the way, there should be minus sign here. Cos 180 means minus 1. Cos 180 means minus 1. So I should put a minus sign here. You can say, okay, work done equal to minus Mgh. So if you pull a object in an upward direction, the work done is minus Mgh to pull upward. And if your object go down, when an object go down due to the gravitational force, let's say object is here and then it is going down. Okay, initial position was here. You move it downwards by a distance of h. So look here, my gravitational force is always downward. Fg is downward. Okay, so work done is Fg dot h, and angle is what this time? Fgh. So Fg and h are along the same direction, downward direction. So cos 0 degree. Cos 0 degree is 1. So this is equal to Fgh. So work done equal to Fg is mass times gravity times h. So this is the work done. This is the work done Mgh when an object is moving downward. So that means we can say that the work done is positive when a object is moving upward, and work done by the gravitational force is negative, is negative when an object is going up, and work done by the gravitational force is positive when an object is going down. This problem omit করব এটা পড়া দরকার নেই, we don't need to do that. So I'll be doing I will do a few more math. So before that, আমি একটু বলি this math. This math you'll find in book. Let's try this one. And this number 5, this will be an assignment next time. So I'll not be doing this one as well. This will be appear in our assignment 2. So by the way, assignment 1 econo due আছে, so assignment 2 will come later. Okay, this will be appear in assignment 2. এটা আমি একটু তোমাদের জন্য রেখে দিচ্ছি, বা আমি একটু hints দিয়ে দিব এই ম্যাথটা।
Yes, sir.
Okay, so but actually time not to have. A father is racing with his son, has half the kinetic energy of the son. Father and son both are racing. Okay, father, son, son একটু ছোট হবে। His father, and this is his son. Both of them are racing together, and father has a mass that is half of that of the son. No, mass of son is half than that of the father, and father's speed is half than that of the. Okay, let's read here. A father is racing with his son, has half the kinetic energy of the son. Father's kinetic energy is ছেলের kinetic energy half, and who has half the mass of the father? ছেলের mass the father's mass is half. The father, if the father is speed up by 1 meter per second, then has the same kinetic energy as the son. Father speed যদি 1 meter per second increase করো তুমি, তাহলে father আর son এর same kinetic energy হয়. What do you have to find? You have to find the speed, initial speed of the father and the son. Okay, let me do it then. So think here. So let's say father and the son. So mass. It's the mass of it. The mass of the father is m. The mass of son is m by 2, and the speed. No. Speed. Let's say speed. Speed of the father is v, and the speed of son is u. Okay. V is the speed of father. U is the speed of son. And now see here what it is saying, that the kinetic energy of father is equal to kinetic energy of son. No, not son. Half of the kinetic energy of the sun. Right? Kinetic energy of father is equal to half of the kinetic energy of the sun. This is saying here, father racing his son has half the kinetic energy of the sun. The kinetic energy of father is equal to half of the kinetic energy of the sun. Kinetic energy of father is what? Half into mass of father into his velocity square. This is equal to 1/2 kinetic energy of sun. Sun's kinetic energy কত? Kinetic energy of sun is 1/2 times his mass. Mass of the sun is m by 2. And his velocity square, that is u square. It's clear. So 1 of m is going to cancel each other. So we can say v square equal to u square by 4, or v equal to u over 2. So the speed of father is half than that of the speed of sun. Babar velocity, sun velocity অর্ধেক. Okay, or বলতে পারি u equal to 2v, যেটা তোমার পছন্দ সেটা লিখতে পারো. Now in the second part they are saying if the father is speed up by 1 meter per second, then their kinetic energy become equal. So that means if velocity of father is v plus 1, father velocity v plus 1, তখন kinetic energy of father is equal to kinetic energy of son. Kinetic energy of father is what now? 1/2 mass times velocity square. Velocity is v plus 1 whole square, right? Equal to kinetic energy of son is 1/2 time his mass. Mass is m by 2 into speed square, u square. Is it clear? 1 of m and 1 of m is going to cancel each other. So you will get v plus 1 whole square equal to u square by 2. Basically, u square means what? U square means 4v square. And then therefore u square means 4v square. So I can say like v plus 1 whole square, or v plus 1 whole square. It can be break up. I can write this as like v square plus 2v plus 1 equal to u square means 4v square by 2. Okay. 4v square by 2. This is basically equal to 2v square. Is it clear? That means 2v square minus v square minus 2v minus 1 equal to 0. And this gives me v square minus 2v minus 1 equal to 0. Right? So what I get? What I get is v square minus 2v minus 1 equal to 0. How to solve this thing? You can apply the formula to solve quadratic function. This is a quadratic function. So v equal to minus b minus এটা তো জানো তোমরা না x square plus bx plus c.
Yes,
equal
sir.
to 0. তাহলে x equal to minus b. So b minus b means 2 minus into minus 2 plus minus b square. B square is 4 minus ac. A হচ্ছে 1 minus 4ac by the way 4. A হচ্ছে 1 and c হচ্ছে minus 1 and divided by 2a 2 into 1. So v is basically equal to 2 plus minus. This is 4 and plus 4 8 by 2. So v equal to 1 plus minus root 2. So basically v has two values. One is 1 plus root 2 and there is 1 minus root 2. 1 plus root 2 and the other one is 1 minus root 2. So there are two values of v. But 1 minus root 2, this is a negative value. So negative value is not acceptable in case of magnitude. So this is not acceptable. So basically this is the velocity of the dad, and then the velocity of the sun will be equal to, so this is one answer. This is one answer. And the velocity of sun will be equal to 2i of this velocity. So velocity of sun is basically equal to 2 plus 2 2. Is it clear? Yes, that's okay. So this is the answer. Is this math clear to you guys? Okay. So anyway, math assignment I already solved it. So this is the math. Number 11. Here they are saying, okay, a 12-meter force with a fixed orientation does work on a particle that moves in a three-dimensional displacement that has a three-dimensional displacement of 2i minus 4j plus k. So displacement is given here. So what is it saying? It's saying a displacement of an object is given 2i minus 4j plus 3k. This is the displacement, and force is also given. Magnitude of the force is 12 Newton, and it is acting along a fixed direction. You see, fixed direction. So force equal to 12 Newton. Now, what is the angle between the force and the distance if the change in particle kinetic energy is 30 joule? If the change in particles kinetic energy is 30 joule or minus 30 joule. By the way, what does change in kinetic energy means? Change in kinetic energy delta K equal to is what? Change in kinetic energy means work. From work energy theorem, we know change in kinetic energy equal to work. So this work done is 30 joule. What I have to find out? Find out work done is 30 joule. You have a displacement of this much, and your force is 12 Newton. What is your angle? What is your angle? Is clear? Angle to what is the angle between force and displacement? Okay. So force is what? Force is equal to work done equal to FD cosine of phi, and this is equal to 30 joule. So এখন a distance d, দেখো d এর ভ্যালুটা এখানে বলা আছে d equal to 2i minus 4j plus 3k. This is the displacement. You see here. Here f and d are magnitude, and this d is what? This d is vector quantity. So magnitude d is what? Magnitude of d or d equal to, আমরা সেই ফর্মুলা অ্যাপ্লাই করতে পারি, equal to 2 square plus minus 4 whole square plus 3 whole square. Is it clear to you guys? This is the magnitude of d. So this is square root of 4 plus 16 plus 9. So this is basically equal to square root of 29, right? So this is my D. So my F is 12. So W equal to 12 times square root of 29 times cosine of 5. That is equal to 30. So cosine of 5 equal to 30 divided by 12 multiplied by square root of 29. And if you have a calculator, you can easily find out the value of 5. Is it clear? Because they were asking for the angle. They were asking for the angle. And this math B is almost 7. Math B is also 7. Here, all you have to do, you just have to replace 30 by minus 30 here. Let's try another math. Yeah. This is the last math, I think, for the day. A can of bolt and nut is pushed 2 meters along an x-axis by a broom along the greasy floor of a car repair shop in a version of shuffleboard. Figure shows the work done on the can by the constant horizontal force from the broom versus the potential position x. The scale, এটুকু পর্যন্ত বলি, একটা ক্যান একটা জায়গায় আছে হয়তো, is a can. ক্যান তুমি করলে একটা ঝাড়ু দিয়ে এই ক্যানটাকে ধাক্কা দিলে এটা করে কি ট্রাভেল করতেছে along x direction-এ ট্রাভেল করলো। Okay, and travel করলে কি হয়, you are applying a force on this can by a broom, and that is why it displays along x direction, and that means some work is done, and this figure shows the this graph shows the work versus displacement. Okay, and here they are saying ws means 6. This value is 6. This means 6. তাহলে this 0 1 2 3 4 5 6. So this is 6 and this is 6. Okay, এটা হচ্ছে work versus displacement graph. Now they are asking for us, what is the magnitude of the force? What is the magnitude of the force here? একটা বোঝা গেল, একটা ঝাড়ু দিয়ে এই ক্যানের উপর একটা ফোর্স অ্যাপ্লাই করা হয়েছে, and that is why it move along x direction, and this graph shows the work versus displacement graph. What I have to find out? I have to find out the কি বের করতে হবে বলো? Force. I have to find out the force. So now look here, we know W equal to Q. We know W equal to F times displacement. If my displacement is x, so F equal to K. তাহলে একটু খেয়াল করো তো এই গ্রাফের দিকে যদি একটু খেয়াল করো, if you just look at this graph, in this graph work is along in which direction? Work কোন direction এ কাজ করছে? Work is along y direction, right? And x is, or displacement is also acting along x direction, and F is the constant force. F is the constant force. So it seems like a constant টাকে আমি যদি m বলি, তাহলে কি হলো, this graph is like y equal to mx, or a straight line that passed through the origin. তাহলে তুমি যদি compare করো, by comparison you can say that the force is equal to what? By force is equal to the slope of the curve, or the force is what? Force is equal to the slope of this curve, right? So force is equal to slope of w versus x curve. So I'm requesting you guys to find out the slope of this curve. All the values are given here. You can do it by yourself. Is it clear? So this is the force. And for part B, they are asking, okay, if the can had an initial kinetic energy of 3 joule, if the can had an initial kinetic energy of 3 joule, what should be the positive work done? Okay, 3 joule moving in the positive direction of x-axis. What is the kinetic energy at the end of 2 meters? So it initially 3 joule kinetic energy chilo, and then let's say this distance is 2 meters. Okay, a 2 meter travel করার পর, what is the kinetic energy of this broom here? What is the kinetic energy here? So initial kinetic energy was 3 joule. I have to find out the final kinetic energy. So what I know that kinetic energy final minus kinetic energy initial equal to work done. The kinetic energy final equal to work plus kinetic energy initial, right? Kinetic energy initial is what? Kinetic energy initial is 3, and work done কখন work done করার বলছে? After, at the end of 2 meter. The 2 meter travel করতে সে কতটুকু work done করে? দেখো, from this curve we see that after traveling 2 meter, the work done by the object is 6. So work done equal to 6. So kinetic energy final is equal to 6 plus 3, that is equal to 9 joule. Is it clear to you guys? Hello.
Yes, sir.
So this is the math. Not very difficult math. You have to actually try these things at home. And here is another math. I'm leaving it for you guys. Parvana? A mathematics for 1547. Like this. So and then these are the homework. This is some homework from this chapter. Okay. So I think you guys will be able to solve this maths. একটু homework try করবে বাসায় এবং হয়তো এখান থেকে আমি কিছু ম্যাথ তোমাদের অ্যাসাইনমেন্টে দিয়ে দিব। আজকে পর্যন্তই থাকছে।
স্যার একটা কোশ্চেন ছিল।
জি শিওর।
স্যার অ্যাসাইনমেন্ট 1 কি হবে না?
হবে না
আমি স্যার মিস করে গিয়েছি।
অ্যাসাইনমেন্ট
2 বলছেন, অ্যাসাইনমেন্ট 1 মানে বাক্সে তো অ্যাসাইনমেন্ট 1 দেয়া আছে, অ্যাসাইনমেন্ট 2 এর কথা বলছেন।